Inside the 1 nanometer transistors, the future of computing.
Imagine shrinking technology so small day by day that it disappears into the realm of atoms like we never experienced before. At just 1 nanometer, we enter a world where matter behaves differently, where electrons whisper instead of flow, and where the future of computing begins to take shape. A nanometer is 1 billionth of a meter, smaller than a strand of DNA, smaller than anything the human eye could ever perceive. At this scale, transistors are no longer just components. They become delicate structures built atom by atom, engineered at the very edge of physics. Inside a 1 nanometer transistor, silicon alone may no longer be enough. Scientists are exploring exotic materials, graphene sheets thinner than reality itself, and carbon nanotubes that conduct electricity like tiny highways for electrons. But something strange happens at this size. The rules change. Electrons begin to tunnel through barriers, ignoring boundaries, slipping through walls, as if the universe itself is bending. Quantum effects, once theoretical, become everyday engineering challenges. To control this chaos, engineers design new architectures, stacked nanosheets, gate-all-around channels, and vertical transistors rising like microscopic skyscrapers. Each layer carefully positioned, each atom playing a precise role. Manufacturing at 1 nanometer feels almost magical. Extreme ultraviolet light carves patterns smaller than molecules, while atomic layer deposition builds materials one atom at a time. It's not just fabrication, it's creation, at the smallest possible scale. Why go this small? Because smaller transistors mean faster processing, lower power consumption, and devices that can think more efficiently. Artificial intelligence, quantum-inspired computing, and ultra-smart sensors all depend on this tiny revolution, smaller than a blood cell. But the path is uncertain. Heat becomes harder to control, leakage currents grow stronger, and the cost of building these chips skyrockets. Every advancement pushes engineers closer to the limits of what's physically possible, but cons are still there. Yet, the dream continues. Computers the size of dust particles, wearable intelligence woven into fabrics, and machines capable of solving problems once thought impossible. The 1 nanometer transistor is not just small, it's transformative. And as we peer inside this microscopic world, we realize something profound. The future of computing won't be built with bigger machines, but with smaller miracle structures so tiny yet powerful enough to reshape the entire digital universe.